The question at hand is, why do they make that noise?
Because the sound has to travel as it goes by, my guess. Because like when it's right next to you, it doesn't have to go far. As it's going further away, it's further.
Oh yeah, it's like that part.
That's part of it. Part of it. Imagine for a moment you got a car.
The Subaru.
And it's sitting still. Sitting still. I'm going to draw it as a big block with a couple wheels on it. It makes a wave with these wavelengths. Agreed? What happens when the car starts moving forward? It makes the same first wavelength. Okay? And that wavelength, by the way, would, then when it gets to here, and that would travel to here, right? But then the car moves farther forward. Right? Oh, it got bigger too. And it sends out its second wave. So what's happened to these waves? They're closer together. If the wavelength shrinks, it's got to go to the same speed. So what happens to my frequency? My frequency goes up. And that's that higher pitch. As a car comes at you, it's higher pitched. As it leaves you, it is lower pitched. Okay?
I'm kind of confused on that.
Police cars use this all the time. They actually spend an awful lot of money and time investing in what is the best place where your ear can discriminate between frequencies. Almost every human being in the United States can tell whether a police car is heading towards them or away from there. I wonder why. Because when a police car is heading towards you, it up frequencies to a higher frequency. When it moves away from its lower frequency. And in our ears, the range they picked, it's distinctive. Okay? And so we really can hear when a police car is heading towards you and when a police car is heading away from you. Okay? You think about it. Think about police cars going by. It's the best, right? And I think ambulances get it better, which is weird. So maybe my ears don't work as well as everybody else's. Good? That makes sense? Okay. Another way to look at it is this. Let's say I'm out there. I'm making waves because I'm a meanie person, and the waves are like this. And you get your boat, and you start going this way. What's going to happen?
They're going to splash on you.
You're going to hit with a lot more waves, right? Mm-hmm. Bang, 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 bang. Now, if you went the other way, there'd be less waves. Lower frequency. Higher frequency, lower frequency. Going towards the waves, higher frequency. Going away from the waves, lower frequency. Mellows you out. Okay? All right. Good so far? Okay. Yes?
It's like the weather thing they use and call it the high-def Doppler radar.
It's Doppler radar. Doppler radar works really simply on the fact that it can only pick up things like water. And so what happens is the radar wave goes out there, hits this water, and comes bouncing back. That's interesting. It tells us where the water is. And that's what we used for a long time to predict weather. But we realized what we really wanted to know is how fast that water is moving. Because that water is moving in a circular pattern or lifting, it changes what's about to happen to the people underneath it. Okay? And how fast it's lifting and how fast it's turning tells us also. Like a tornado can be picked up from the fact, even when it has very little water in it, those water particles moving at 80, 90 miles an hour tell us, uh-oh, something bad's happening. Especially if I got water coming this way, and going that way on the other side, right? So when I hit it with a radio wave, it comes back as higher frequency because it hits something and it's re-emitted by something moving towards me. So I pick at a higher frequency. That's by the way how a police car picks up its uses Doppler radar as well with its radar guns, right? As your car is coming toward, they hit it, it bounces off the front. How fast you're going determines how close these waves are packed. It determines how fast you're going. I can tell you how fast you're going because of how much it shifts up or down. In fact, this is also what we use, since we're there, Redshift, Blue Shift. Okay?
Redfish, one fish, two.
If you're heading towards me, you'd be higher frequency. If you're heading away from me, you would be lower frequency. If you're heading towards me, that means you should be bluer or purpler. If you're heading away from me, it means you should be more red in coloration. Now, you have to be going near the speed of light. So therefore, most things, this does not matter. But it does matter for cosmological objects. For example, galaxies. One of the most profound discoveries we discovered not so long ago is here's the Milky Way. Here's where we are. And we looked at every other galaxy we could find. You know what they all are? They're all redshifting. Every last one of them is redshifting. That means they're all moving away from us.
All the other galaxies?
Every other galaxy, all the other clumps of stars with 200 billion stars in them, every last one of them is heading away from us. Every last one of them.
Isn't Andromeda supposed to?
No, Andromeda is still heading away from us. Now, Andromeda is slowing down. Its redshift is getting less, which appears to be because our gravity is starting to pull on theirs, and the gravity, which means we may actually end up pulling ourselves back in and slamming into each other sometime way, way in the future. You know,
Like 10 years. We'll get to it this late.
Tens of billions of years. Okay, so not really looking forward to any time. Our sun will probably go out before we run into them, but that's a sort of thing. But that's okay. We can move. Now, this could be caused by one of two events. One of which would be that we're the center of the universe, which we've hopefully gotten rid of by now, because every time we say we're the center of the universe, we're wrong. The second possibility, which is more interesting, is if the whole universe, if we're here and we're going this way, and every other object in the universe we're moving outwards, then every other one would effectively be moving away from us. Right? So if everything was moving out from a central point, say, everything would appear to redshift. What do we call this idea, by the way? It's called the Big Bang. This is the primary reason why physicists believe the universe started with a Big Bang. Because everything is still going what? Outwards. By the way, there's a Bell Labs swivel a telescope. They were trying to make infrared telephones back when they were trying to do cellular phones because radio waves wouldn't work. I'll go. You too. You need to go in the hallway? Seriously. Okay. Okay. When they swung their telescope all over the place, they were trying to figure out what background radiation would run into because infrared cell phones is what we're going to have. Now, infrared is like what you use the old remotes, the little red lights and thing, you push the button. Not really great for this, and that's why you don't have an infrared cell phone. But they thought this was the way they were going to do it. Okay? And while they were doing that, they swept out the whole entire sky. And when they discovered a very strange thing, there's one spot in the universe, which, by the way, if you backtrack everything back to that spot, this is still warm. Still warm space because it's hot. Okay? And there's nothing there. It's just a warm spot. Yes, sir?
Do we know the direction to the sun?
Yes.
We can look at it. Which one's
Yes, we can actually, the Bell telescope people have actually put it back there. Now here's how you do it. Now watch this. Andromeda is close to us, right? It's redshifting very little. Why? Because only this component matters. Only the component where it's moving away from us, like this component here, matters.
Yeah.
This component's the same direction, and we wouldn't notice that at all.
Yeah.
So the ones over here are very much moving away from us. We can tell their full speed, they're completely moving away from us. And that's consistent. Closer ones, small redshifts, farther ones, big redshifts, which is part of the idea that we're all moving out from a central point. Because of that, if you're careful, you can make a calculation and start backtracking everything back. Okay? This is where we get the universe is only 12 or 13 billion years old. Okay? That's it, start to finish, 13 billion years moving around. Okay? And that we all came from a central spot. And that central spot can be tracked with a telescope. Now, the fact that they match up is just too convincing for us to say that's not the spot. Could it be these objects actually traveled back through each other? Maybe. But right now what we're also discovering is that if you take the speed at which these things are traveling and you just do backwards time stop, we all end up in the same place at the same time.
Why don't they just calculate the speed of like our galaxy?
When you do a Doppler, you're getting speed. That's what you're getting. That's what the radar gun gets you. That's what the speed. How much you redshift is how fast you travel relative to us. Yeah.
So energy travels in waves, right?
Hey, a wave is a carrier of energy. Yes.
Okay. So if there's nothing in space, it's empty space, right? There's nothing for sound waves to travel through, say.
Yes.
How can that spot be warm?
A good question. It's still emitting heat.
But how can it emit heat if there's nothing there for the wave to travel through?
Because there's something.
Space is not getting.
All right.
Probably Jackson's.
The short version, which we'll discuss after the AP test. the universe, the space itself is something. What it is, we don't exactly know. There's something there.
So space is.
And that something can be warped. It can be twisted. It can be shook. Okay?
But it's not
In fact-
matter as we understand.
In fact, as the Earth was traveling a year and a half ago, we have something called the Very Large Array. It's basically a long tubed laser in it. As that tube traveled through space, we traveled through a gravitational wave, which is a bending of space, and it deflected our laser. Okay? It just rippled our laser as we went through it. Now, this is happening. This is real. This is and I will give you a better explanation for this later and why we know this is true. It is true. And that rippling is still going on in the middle. That unsettlement is going on in the middle. And that creates heat. There's still echoes from that blast. By the way, you'll read Time magazine saying that we're listening for the sounds of the Big Bang. There's no sounds in space. We're looking at these ripples in the space itself to try to figure out what's going on. Yes.
Wild.
I've always heard that space is nothing, but space is a thing.
The answer to your question is yes, it is nothing, and yes, it is something. And I can't do better than that until we talk about it at more length, which I'm not going to do because we're going to run out of time. But one of the things you should also be aware of is all waves must travel by shaking a media. We get light from the sun. Contemplate what that media has to be.
What medium?
Something's wrong there, right? There's nothing you can shake between the sun and because there's nothing there.
There's air, isn't there?
Thanks, Brent. There's no air between. There's a little air between us and the top of the atmosphere. Once you get out of the air capsule around planet Earth, you're in space. There's
What's that
nothing
stuff?
there.
Nothing?
Nothing.
What?
Whole lot of nothing. In fact, there's so little nothing that if you open your door to your spaceship, all your air will go out. It'll blow up like a bomb and go out the door. And you get sucked out too, probably. And by the way, if you hold your breath, you'll explode in space.
What?
There's nothing out there. There's so little out there. If you had a balloon, it
But
get
what
bigger.
are you in?
There's no atmosphere.
Like what is?
Get in a spacesuit. What?
I know you're in a spacesuit, but what are you in? Like, what is that stuff surrounding you? Then? Nothing? How can that be?
There's nothing.
There is. There has
There's
to be something.
nothing. Nothing.
What? I should have.
Why does it have to be something?
Because there needs to be something.
There's nothing. Yes.
So what is the Doppler effect?
The Doppler effect is effect. If you're heading, shh. If you're heading into the waves or out of the waves,
That's so weird.
you create a different your apparent frequency is different than your real frequency. Okay? Your apparent frequency is different than your real frequency. You sound higher pitched than the guy in the car is emitting. Okay? Because they're being emitted closer together. Okay?
Wait, what was it?
Apparent. That's what I hear, even though I'm what I see, right? Apparent.
Like a parent.
No. Although that can be used.
Apparent?
Okay.
Like an AP? Like
Okay.
apparent.
I'm going to leave this discussion for later. We have more to talk about when we get to Doppler effect, but not yet.
Wait, what was it? I missed it.
So redshift is if something's moving away from you, it's going to appear more red, lower pitched. It's going to be blue shifted or purple shifted if it's heading towards you.
So that
Sound?
one's purple? Wait. Does that mean just
No,
purple?
there's nothing up there that would be red shifting or blue shifting. They're just naturally purple. Okay.
Well, that's not
But if you look at stars, all stars emit the same color of light.
All
white.
Now you should know that because in chemistry you saw it. Hopefully you got out the tube. You looked at hydrogen. You didn't look at hydrogen tube.
No.
Okay. Anyway, take a quick. We'll talk about that later if we get a chance.
Wait, I kind of missed this.
Okay. So redshift, moving away from you. Blue shift, it's going to look more red if it's moving away from you. More blue if it's coming towards you. It sounds higher pitched coming at you. It sounds lower pitched when it moves away from you. Good?
So red is
Okay.
going away,
What
right?
about at the racetrack?
Right. How the racetrack's the noise he makes. He'll make it for you.
What if this was a right?
You're supposed
Whatever.
To,
This is your job. It's not my job to describe that.
And blue's coming
Get in
towards
there.
you, right?
Running out of time. Okay.
What?
I just read.
All right.